Hello, I'm Brandon Doyle, and this is my Week 6 assignment for Introduction into Ammunition and Basic Ballistics. Today is July 11th, 2025. Let's get started. Today, we're going to talk about 7 factors that affect external ballistics. Alright, first we'll talk about trajectory and sights. When it comes to trajectory and sights, the sights of the firearm are going to allow you to see the line of sight. It will give you a basic understanding of where the trajectory of the bullet is going. The best way to get your sights as accurate as you possibly can is to get it to the point of zero. For those who don't know what the point of zero is, it's the distance between the muzzle of the firearm which the projectile intersects with the line of sights. Zeroing at 30 yards is most beneficial for short ranges, giving you more linear trajectory. But for those that are zeroing in a rifle, the rifle will look like it's aiming this way, but the barrel is going to be aiming a little bit up due to zeroing in at further ranges. The reason why is because it's going to go like this, eventually passing back into the line of sights due to gravity. Alright, now we're going to talk about gyroscopic drift, or spin drift. That is a phenomenon that is caused when a spinning object has force applied to it. But instead of it going in the same direction, it's going to go perpendicular, which means 90 degrees in a different direction. Depending on whether or not it's spinning right, it's going to go right. If it's spinning left, it's going to go left while it's being forced down by the gravity. Now we're going to talk about the effects of drag. Drag is the effect on the projectile being slowed down by friction that is caused by the density of air. Even though the air is a mixture of gases and vapors, it acts like a fluid by the way it flows. That's why aerodynamics is an offshoot or subcategory of fluid dynamics. Because of that, it makes anything moving at high velocities feel like it's going through fluids. And depending on the temperature, the air density can be thicker or thinner, causing more or less drag, causing the bullet to slow down much more depending on the temperature, reducing the distance of it flying. Now, with the Magnus effect. The Magnus effect sounds a bit like the gyroscopic drift, but stay with me. The Magnus effect is a phenomenon that occurs when a spinning object is moving through a flowing fluid perpendicular to its rotational axis, which means crosswinds. Those crosswinds are going to have an effect on the projectile depending on whether or not it's spinning right or left, as well as the dependence on whether or not the wind is blowing it in certain directions, as well as whether or not it's decelerating or accelerating the wind flow. With that being said, if the bullet is spinning clockwise from the shooter's perspective and the wind is blowing from left to right, this will create a lift in the projectile's trajectory, causing the nose to point up, causing the bullet to have less drop due to it riding the pressure area. But if the wind is blowing in the opposite direction, right to left, it's going to cause the nose to point down, causing it to dive sooner. Alright, now we're going to talk about the Coriolis and Yavis effects. Both of these effects depend on whether or not you're shooting very far distances. The reason why is it is entirely affected by the rotation of the Earth. If you're shooting from the northern equator, north or south, you are going to miss on your right side because the equator goes way faster than the north or south pole. If you shoot upward, south to north, you're going to miss on the right side because the North Pole is going slower than the equator. But if you're shooting north to south, you're also going to miss on the right side because the equator's going faster than the South Pole. And it's the same with the South Pole, but in reverse, going to your left. But for Yavis, that impacts the projectile on an east to west direction. Depending on how far you're shooting, which way you're shooting from, east to west, the bullet will go above the target. But If you're shooting from west to east, it will go under because the Earth is rotating and you are falling or rising, depending on which side of the planet you are shooting at. Now, let's talk about vertical angles. Vertical angles are not some kind of deflective force that messes with your trajectory. It is merely a miscalculation of distance. You are a lot closer to the object than you realize, and because of that, your shots will be a little too high, regardless of whether or not you're shooting up or down. Alright, now we're going to talk about transonic ballistic performance. For transonic ballistics, this is when the bullet is going supersonic, but is slowed down by all the drag, to the point it becomes subsonic velocities. Once the subsonic velocities are reached, the drag will be reduced, but because of that, the forces will cause it to shift further ahead of its center of gravity, causing the bullet to wobble and cause it to go off of its intended trajectory. And with that, that'll be it for today. Hope you all had a great time. Have a good one.